Alright folks, here we're looking at me change the color of my marker. Sorry about that. Going for a nice pea green pea soup. We're looking at number 2 here, and we're trying to figure out the delta H for this reaction here. We got barium oxide combining with sulfur trioxide to form barium sulfate. And here we give our values for delta H naught. If this problem didn't give them to us, we'd be able to look them up in our reference guide with our tables of delta H's. So here it's going to be just the sum of the delta H of our delta H naught of our products minus the sum of our delta H naught of our reactants. This is actually just the Greek letter sigma, means sum, just like in math class. If you're summing up things, you're adding them together. So whatever the delta H naught values for our products are, here we only have one of them. We're going to subtract from that the delta H naught of our reactants here. Notice here we don't have any coefficients. This is just, if you see that, just double check, make sure it's balanced. In this case, it is. So that means we're just going to use these numbers really as is. So for our products, barium sulfate, looks like barium sulfate's delta H is negative 1,473 kilojoules, or kilojoules per mole if we were producing a mole of that. So we're going to take negative 1,473 kilojoules per mole, and we're going to subtract from that negative, for the barium oxide, 548 kilojoules per mole. And I guess I didn't need to do that. Let me see if I can step backwards there. There we go. And then we're going to add the delta H of our sulfur trioxide, and that's going to be negative 395.7 kilojoules per mole. So if I do this, plug this into my calculator, negative 1473 minus a negative 548 plus negative 395.7 kilojoules. That will give us our delta H naught of this reaction. If we do this, we should end up with 529.3 kilojoules per mole as our delta H naught. And that's it for this problem.